talk about radiation detection and measurements. I'm Dr. Pervez Ahmed. So let's talk the first topic. Before to proceed about the proper radiation detection and measurement, let deal with some of the key phenomena related with radiation detection and measurement. That is, in the first part, we will talk about the interaction of particle with the matter. And this regard, the first topic is photo emissions. What is mean by photo emissions? Let's have a brief introductions of the photo emission. Just like you can see it in the figures, the basic phenomena related with the photo emissions. So we have excitations followed by de-excitations. What is mean by excitations? Excitation means atomic electron is promoted to a higher energy states by energy provided by the particle. Just like you can see it here, we have the particle, we have the atomic electron, and this atomic electron, when it gets energy, so it's been promoted to the high energy state, and it's remained in this high energy state until unless it has that particular amount of energy. So what actually happened when it's emit this particular amount of energy, so it's fall back to the ground state uh, and release that energy which has been absorbed in the form of photons. The next we have an interaction of particle with matter. The terminology is ionizations. Again, you can have the figure. I mean, you can observe here what's mean by ionizations. So let's have a proper definitions for the ionizations. What is mean by the ionizations? So in ionizations, atomic electron is knocked out. Atomic electron is knocked free from the atom. That is, for example, you can see it here. We have an electron here, and this electron is knocked from this particular positions. So this particular phenomena we call that ionizations. So what we have, the remaining atoms now has charge as well. That is, we can say it is an ion. I mean, when knock out the electron, let's suppose this is a particular atom. You can observe it here. From this particular positions, we knock out an electron. So we are behind this electron, we are left with the ion. I mean, the atom that we are left with after the electron is being knocked out, we call that an ion. In other words, you can say that the atom may also be left in the excited state and emit photons. So this is also the possibility. But if you are a solid state physicist, you're working in the field of solid state physics, so you call the ionized atom as a whole. I mean, when you knock out electron from these particular atoms, and you're working in the field of solid state physics, so the lab which left behind, I mean, from where you have knocked out the electron, you call that as a hole. I mean, the hole is basically the vacancy for the knockout electron. Collective effect, I mean, is a part of particle interaction with the matter. So what is the collective effect? Just like the previous, we are discussing that the electric field particle may have a long range interactions with the materials as it passes through a continuous mediums. So in that particular phenomena, we can observe Cherenkov effect, I mean, which turn on when the particle speed is greater than the light speed in the medium, that is v is equal to beta c is greater than c by n. So here you can observe that we have this particular phenomena in the figure. So when it's reached, when it's turned on, so what you can observe at this particular location, I mean, is I mean, with no time it's go up, and you can observe the Cherenkov effect. So just like you can see it here, the electron flew up when this particular I mean, with this particular parameter is reached. I mean, we can observe this phenomena. How you can have a look again. Okay, what happened in this particular situations? I mean, when we have this point, I mean, the Cherenkov effect is turned on when the particle speed is greater than light speed in the medium. So we can discuss that later on, or maybe you have probably known about this when you were studying the modern physics. But maybe later on in this course we can also deal this topic again. So what actually happened, and Cherenkov effect, we say that light is emitted at an angle that is theta is equal to cos inverse 1 over beta n. That is, this should be the theta for light emissions. That you say the light is emitted in this particular angle. I mean, here you can observe this is the theta where we say that the light should be emitted at this particular angle. So photon energy should be a few electron volt, which mean that it should be from ultraviolet to visible range. I mean the light energy should lie in this particular range. I mean it should range from UV to visible. uh, uh, Collective effect. So in this particular effect you see we can have transition radiations, that is the sudden change and the electric field. uh, what is their sudden change? The sudden change in the electric field as an ultra relativistic charged particle passes from one medium to another medium. So it results in energy approximately equal to an electron volt photon. So in ultra relativistic effect, what we have the photons with the energy approximately, I mean, it's greater or approximately equal to 1000 electron volt. That is what we have. We have gamma is equal to 1 minus beta square, uh, 1 over whole under root, which is equal to E by m. So light is emitted again at that particular angle that we call theta. It's approximately equal to 1 by gamma, and here you can observe that how light is emitted. I mean here you can see the phenomena that when the light is entering from one medium to the other medium. So in this particular situation we can observe the ultra relativistic effect. That is when we are passing the light or charged particles from one medium to another medium. So that this is the key thing you can observe. Interaction of particle with matter. During the interaction of the particle with the matter, we can also have radiation damage. That is, a particle can have a lasting effect on the detector material. For example, if we have a detector with which we want to detect the particles, or you want to look at the particles, so we remember that detector material can also be affected by the interaction of the particle. In some cases we can say that those detector material can be damaged by the interaction of the particle. So during this interaction, the interaction of the particle with the matter, we can have nuclear collisions, which we can discuss further in full detail later on in this particular course. So when nuclear collision occur, so the particle can undergo the interaction directly with the atomic nucleus. I mean, this is the one kind of possibility. That is the first kind of possibility. The particle can undergo interaction directly with the atomic nucleus. The second possibility is that that particular particles may transmit the elements, that is radiation damage. The third possibility is that during that nuclear collisions, it is possible that it may lead to secondary particles which themselves are detectable. I mean, these are the three possibilities when we have nuclear collision. We can have lattice dislocations. So what is meant by lattice dislocations? Due to interaction of particles, we can have a crystalline structure of a material which may be disrupted. I mean, we say that if you have the particles and you are interacting that particle with a particular type of crystalline materials. So be remember just because of the interaction of that particle with the crystalline structures, so it's also possible that the crystalline structures can be disrupted due to the interactions of the radiations. We can also have chemical change, that is photographic film or emulsions. During the interaction of the particles, the chemical change, is also possible in the materials, which you can observe on photographic film or emulsion. So what we have, while these effects can be exploited as a type of particle detections. They may also cause permanent damage to the detector component, which in other words can result in a detector will stop working. So this is something referred to as edging. So while we are having a detector with the help of which we want to detect the particles, so we remember we actually made the particle to interact with that detector's material. So during this kind of interactions, the particles may also damage the detectors. So when this kind of thing happens, so we say that the material in such a condition, the material is not working, and we call this as aging of that particular materials. So during these interactions, what's the effect on the particle? So for a particle to be detected, it must interact with our apparatus. If we have a detectors or if we have an apparatus with which we want to detect the particle, so what we have to do, we should make a particle. If we want to detect a particle, so first of all, we should have to make the particle to interact with our apparatus. That is, we should have action and reactions phenomena. So what we can do for this, the properties of the particle may be different after we have detected it. Initially the particle may have one type of properties, but when it's been detected, so the properties of that particle may not be the same. Why? Because one of the following can occur. It can have lower energy, it may have different momentums, we can say the directions, or we can say that completely stop. This is how we say that the property of the particle may be different after we have detected it. Why it should be different? Because we can observe change in energy, we can observe change in momentum, or we can say that the particle can be completely brought to rest. That's why we say that the property may not be the same after it's been detected. So in fact, one method of determining a particle energy is simply to measure how far it can go before stopping. So in summary, what we can have during the interaction of particle with matter. So the first thing is, when particle passes through the matter, they usually produce either a free electric charge, which we call ionizations, or light, which we call photoemissions. So how can we use this? So the most important thing is, the particle detector usually detect the light or the charge that a particle leave behind. So in all the cases, we finally need an electronic signal to record, and that electronic signal, in other words, give us a sense of the particle detections. So that's all for the interaction of particle with the matter. And the next lectures, we will talk about different kind of radiation detectors. So till then, I think it's okay.